One video and you learn every formula on area of 2D surfaces. Let's begin with three-sided polygon triangle. Whether acute, right or obtuse, if you're given base and height, area of triangle is 1 by 2 base into height. When encountered with sides of triangle, use the Heron's formula square root s minus a, s minus b, s minus c, where s represent a plus b plus c by 2. But sometimes only two side length and included angle is given. Then use the area formula 1 by 2 a into b sin c or 1 by 2 b into c sin a, 1 by 2 a into c sin b. But there are some miscellaneous formulas for area. Area equal to r into s. R is the in radius, which is radius of the largest circle that can be inscribed inside triangle, touching all the sides. And s is a plus b plus c by 2. Similarly, we have the area formula ABC by 4r, where r represents circumradius, which is radius of the circumcircle that passes through vertices of triangle. Now we'll see some special cases for isosceles and equilateral triangle. In an isosceles triangle or triangle with two equal sides, area formula is given as b by 4 square root 4a square minus b square. Interesting thing about isosceles triangle, angle opposite to equal sides are always equal. Also, perpendicular drawn from vertex common to equal sides bisects the opposite face. Coming to the equilateral triangle with all equal sides, area is square root 3 by 4 a square. These formulas can solve any question related to area of triangle. Before moving to the circle area, an amazing fact about area of triangle, if triangle have same base like AB and lies between same parallel lines, they are equal in area. If we keep shifting this triangle anywhere between the two parallel lines, their area will always remain equal. Because area is dependent on base and height, which never changes. Coming to the circles, area of circle is given as pi r square. If you extend this for diameter, area of circle is pi d square by 4. Coming to the semicircle, divide the area of circle by 2 and you get pi r square by 2. Next is very important to calculate for area of a ring, that is area between two concentric circles, pi capital R square minus small r square. Let's move on to area of a sector. Now sector is this yellow pie shaped portion enclosed by two radii and an arc, and its area is pi r square into theta by 360. Extending this idea, we get segment, which is sector minus triangle formed by two radii, and its area is area of sector pi r square theta by 360 minus area of triangle. If you remember, we studied this formula of triangle when two sides and included angle is given. 1 by 2 r square sine theta. Next comes ellipse, which is an oval shaped curve, and its area is given as pi a into b. Now we are only left with area of quadrilaterals. There are three methods to calculate for quadrilateral. In the first method, if you are given diagonal length and perpendicular height from the opposite vertex, area is calculated by adding the two triangles. So 1 by 2 d into h1 plus 1 by 2 d into h2, or simply 1 by 2 d h1 plus h2. both diagonal length and one of the angle is given, area is 1 by 2 d1 into d2 sine theta 1, or you can write sine theta 2, because theta 1 plus theta 2 is 180 degree. Sine theta 1 is equal to sine 180 minus theta 1, therefore sine theta 2. Both these area formula will give the same result. Third formula for area of quadrilateral, when all the sides of quadrilateral is given. It is square root s minus a, s minus b, s minus c, s minus d, where s is a plus b plus c plus d by 2. Now we'll talk about types of quadrilateral and their area. First comes parallelogram. It's a quadrilateral with opposite sides parallel and equal, and area is b into h. There's one more formula for parallelogram. When both the sides and an angle is given, area is a into b sine theta 1 or a into b sine theta 2. Since theta 1 plus theta 2 is 180 degree, sine of both the values will produce the same result. Next comes trapezium, which is a quadrilateral with only two sides parallel to each other, and its area is 1 by 2 into sum of parallel sides, that means a plus c, into height. Now we'll talk about rectangle. Rectangle is a parallelogram with all angles 90 degree. Area is multiplication of adjacent sides a into b. Next is rhombus, a parallelogram having all sides equal. It has two area formulas. If you remember the quadrilateral formula, 1 by 2 d1 into d2 sine theta. In this case, theta will be 90 degree because diagonal in rhombus intersect at 90 degree. Sine 90 is 1. Area become 1 by 2 d1 into d2. And second formula is a square sine theta. Coming to last and simplest quadrilateral square. Square is combination of rectangle and rhombus. That means all angles 90 degree and all sides equal. And its area is a square.